So as you were streaming into the room, I had several statistics floating across the screen, and they were statistics really about the unfinished development agenda on the globe and the huge need in developing countries. And I interspersed those with drawings by children from around the world. UNEP, pardon?
We need more volume in the back.
More volume in the back? Can you hear now? I'll try to speak louder. And I interspersed the quotes with drawings from children. It was a contest that UNEP held, and they asked children to draw their image of what climate change would mean. And you saw lots of happy images of a green world with plants and animals and solar panels, but you also saw the image that the children of Bangladesh drew, which was that of sea level rise and of drowning their communities. So I wanted to remind you that the report we're going to talk about really looked at climate change with a development lens, and I think it was one of the few reports that's actually done that. We consulted with 39 countries, and in the process of doing it, we heard that development prospects were already being hampered by climate change. So for example, in consultations in Africa, we heard that an increase in both droughts and floods which were not that common in Africa, are diverting overseas development assistance monies now, such that they actually had less money to develop with based on, as they called them, climate shocks. So I want to start by saying we must combat climate change, but we have to do so in a way that continues to alleviate poverty among the poorest of the world and allow them to develop. We started our report by accepting the scientific consensus that climate was changing. And I know there's been quite a bit of controversy about ClimateGate in the press recently. But despite that, the climate change science is really much more solid than it was 20 years ago when I first started studying it. And what I have on the screen for you are the three concluding sentences of the multi-year Intergovernmental Panel on Climate Change Consensus reports. And I wanted you to compare what they said in the first panel, which was 1995. The balance of evidence suggests a discernible human influence on global climate. So they were saying, we think we see a human fingerprint. By 2001, the next time the world assembled the science information, they said there's new and stronger evidence that most of the warming observed in the last 50 years is attributable to human activities. Much stronger only a few years later. And in 2007, warming of the climate system is unequivocal, and they use terms like very likely, which they qualify as meaning a greater than 90% certainty that the observed increases in anthropogenic or human-caused greenhouse gas concentrations are causing this. So for those of you who are scientists or hang out with scientists, you can tell me these kinds of declarative, relatively unqualified sentences are fairly rare. So the science has been improving recently. This next slide shows you the 120-year record of temperature on the planet. That's about how long we have good thermometer measurements from many hundreds of thousands of places. And if you draw a line through that 150-year trend, you can see that the rate of increase is about that. If you draw a line through just the 100-year trend, you can see it's getting steeper. If you do it through the 50-year trend, it's getting steeper still. And if you go through the 25-year trend, you can see it's steeper still. So there's a change. The rate of change in the last 25 years is roughly 4 times that of what it would be averaged over the 150-year record. And so the temperature increase on a global scale that's been observed is about 1 degree over the pre-industrial levels. And there's about another ½ degree centigrade in the pipeline from emissions that are already in the atmosphere. And a number of reports have been calling for trying to limit the increased temperature to about 2 degrees C above pre-industrial levels. And that's based on looking at what we expect the impacts might be when you hit 2 degrees C. And I'll show you those in a minute. But not only are we confident that the global temperature is increasing, if you look at this next slide, you can see that temperatures are increasing on each continent too. And here, the black line is the temperature measured. The pink band is what the models project the temperature should be as greenhouse gases build up. And the blue band is what temperature should be if there was no man-made greenhouse effect. So on every continent, you're seeing that temperatures are increasing. You're seeing that the models are doing a pretty good job of projecting that temperature increase because the actual black line is inside the pink band. And you see in a couple of regions, particularly Africa and Asia, the temperature increase is already at the higher end of what the models project. So we have improved confidence that our models are including the key features that explain climate change, because as climate has changed, as we use our models, we can see that there's synchrony there. And now I want to just click through a whole series of things that the scientists also called unequivocal. So in the next slide, you can see that we'll just click through these, Regina. Surface and tropospheric temperatures are increasing. Atmospheric water vapor is increasing because as you warm the planet, you're evaporating more. The heat content of the ocean is increasing, and now we have directly linked the warming of the ocean to expansion and sea level rise. We've seen both the Greenland and Antarctic ice sheets losing their ice mass, and in fact, Greenland melting at a rate way faster than our models predicted, so sometimes uncertainty cuts in the wrong direction. We're seeing glaciers and snow cover decreasing around the globe. The Arctic sea ice also disappearing at a very fast rate. That's floating ice, so when that melts, it doesn't add to sea level, but of course it changes the reflectivity from a white surface to a dark surface, and you get an amplification of heat absorption. And we've seen that the Northwest Passage has been opened. The area of ground that's frozen has been decreasing annually, even in Michigan. There's more intense and longer droughts. This is true on every continent for every decade of the last 5 decades. We're seeing heavy precipitation events increasing, so the rain that's falling is not only more rain because it's an amplification of evaporation leading to more water having it come down as either snow or rain, more precipitation total, but also more intense rainfall events. And we're also seeing the highest temperatures increasing. Tropical cyclone, or as we would think of it as hurricanes, their intensity increasing once they form. Not necessarily more hurricanes forming, but if they form over warmer water, the speed and the energy content and the water increases. And in terms of impacts, we are already seeing the impacts of climate change on the planet. And this map has, this next chart shows you an icon, and everywhere there's an icon, that is either a change in a physical parameter, which are the orange icons, or a species range in the maroon icons, that things are shifting in concert with climate change. So we now have, for example, 20,000 data sets from around the globe that are more than a decade long that are showing that species are on the move, and that species are moving the equivalent of 10 meters per decade up mountains, or several kilometers per decade towards the poles. So species are beginning to shift. We've seen things like the red fox that's been moving into Arctic fox range. We're seeing birds arriving much earlier in the springtime. We're seeing things like marmots coming out of their hibernation 23 days early. So they've used up all their fat reserves, they're hungry, but their food source is not yet ready. So things are becoming sort of out of synchrony as the temperature's changing and the climate map is shifting over them. We've also seen in the United States, as this next chart shows, that the hardiness zones have been shifting. And so you see on the left the plant zones in the 1990s, and on the right the plant zones in 2006. So that's only less than 2 decades. And you can see how the colors have shifted. So I think particularly if you look at a state like Pennsylvania, or if you look at Wisconsin, you can see that the colors are changing. And these hardiness zones are based on the coldest temperatures observed. So what's happening is the plants that you used to grow in your backyard are now the plants that you can grow now are plants that were about 120 miles south of you less than 2 decades ago. And so the plants are on the move, and we're seeing, for example, dogwoods in Nebraska, which is quite amazing, and the warmer, wetter weather you see in New York is causing problems for the Canadian hemlock and enhancing their pests. Species have to move fast to keep up with the changing climate, and the rate of movement is 25 to 45 feet a day. So if you can think about the things that are wind dispersed, or things that fly can do that, but things that are wind dispersed may not be able to. And if you then think about whole ecosystems trying to keep up with this 25 to 45 foot movement a day towards the poles, you can see how there would be incredible disruption in ecosystems. In fact, this next chart shows you what the U.S. forests will look like. On the left, the distribution of forests today. I don't expect you to read the species, but just notice that the forests of tomorrow, the map on the right, is a much simpler color scheme. So it's not that we won't have forests, but we'll have different forests. And the ones you're losing in particular are the reds that you see on the left and not so much on the right. And those are the maple trees, you know, so important for not only our fall foliage, but also for our pancake syrup. And so the maples are shifting right into Canada as the next, and if you click again, we would be saying goodbye to our fall foliage. So let's get more in detail. I said the science is sound. We started with that. And let me now do what some of the messages of the World Development Conclusions from our own analysis is. So this is again showing you that 2 degrees, which is where that line is coming down, is a point at which a number of these impacts listed on the left side become problematic. And so again, this is why a number of reports have said if at 2 degrees an extra billion people are exposed to water stress, 20 to 30% of species are at risk of extinction. The coral reefs will be gone. 2 degrees is definitely a temperature increase that we would wish to avoid. But as I already said, we've got 1.5 degrees in the pipeline. It's going to be very hard to stop at 2 degrees. And I will show you what it will take technologically to do that in a bit. So if we move to the next slide, this is what the World Bank report says. So we argue, of course, that the climate change is an immediate threat to development, that development has many, many challenges. But if we don't address climate change, it will be an increasing problem because climate change interacts with so many of the other development challenges, the availability of food, the availability of water, the availability of shelter, and that climate change will make protecting people from droughts and from floods and from forest fires all that more difficult. But we do argue that a climate smart world is possible, and we argued a lot about what to call that, but we decided climate smart was better than climate resilient, because resilience felt like a passive concept. And we argue that countries developed or developing must control the threat now by very active mitigation to reduce emissions and also active adaptation. And it's quite clear that climate change could alter the competitive advantages of different countries. I mean, the countries that are blessed with sun and wind and forest might be able to capitalize on them and make money. So we're after a climate smart world where the benefits that can be had are appreciated, but a world in which growth occurs without environmental catastrophe is also realized. We're trying not to be Pollyanna-ish about it, and we say that a climate smart world is not going to be easy to create, that it requires incredible political will, popular will, substantial financial effort, and really, I would say all the tools of diplomacy and finance and innovation that the world can actually muster. It definitely requires acting now to address both the urgency of the problem as well as tremendous inertia in the climate system. It requires acting together for a number of reasons, for both equity and efficiency, and I'll show you examples of that. And it certainly requires us acting differently than we have in the past, or we will go sailing through that 2 degree world to a 4, 5, or 6 degree world, an average temperature increase over the next century, which of course is magnified at the poles. So it's really going to require the tremendous ingenuity that the human race is capable of to tackle this complex problem that really affects everyone. In the next slide, climate change is deeply unfair. And what I show you in the left pie chart is historical emissions. So you see the developing countries historically, this is 1850 to today, have emitted 35% of the emissions, and the developed world, the rich countries, over that same time period, about 64%. Now, if the next click will show you a hatched area appearing in the blue, and if we did on a per capita basis from 1850 to today, that hatched area would be the area that the rich countries have overused on a per capita basis, and that if you click again, no, oh dear, can you go back again? So there should be, I can't see it from here, there should be a yellow bar popping up between the 64 and 36. Do you see something there? No. Well, there would be a sliver that's so tiny it's not even apparent. And that would be a 2% of this entire pie would have been contributed to the atmosphere by the 1.2 billion poorest people on the planet. And so I show you this because in all the conversations about climate change and negotiation, equity and the unfairness of it come up all the time. And so per capita emissions, the overuse of the atmosphere by the rich, and the poorest emitting only 2 to 3% are things that come up all the time. The right pie is showing you that in terms of impacts, the reverse is true. 80% of the impacts will be borne by the developing countries and only 20% by the wealthy. And in part, that's due to this next graphic, which shows you how agriculture is expected to change worldwide over the next century. And as you know, the developing countries probably have a disproportionate share of GDP due to agriculture. This chart is showing you red is a reduction in agricultural productivity and green is an improvement. You can see who the winners are and you can see who the losers are. The countries who are already very poor, subject to poverty, are those that stand to have areas of the darkest red up to a 50% reduction in their crops. And this is a composite of 12 crops. We did wheat, rice, maize, millet, beet, soybeans, sweet potato, and 3 oil crops. And this is in the year 2030. Even in this world, there is enough food to feed the population of 2030, but clearly we have to have a very different food distribution system to be able to get it to those who need it. We've been talking quite a bit this week about the Millennium Development Goals, and if these will click through one at a time what the various goals are. So they are to have poverty, and you can see we can just run through all 8 of them. And they're quite a rich discussion of whether or not we're going to achieve the goals that are set in these 8 by 2015. And I think what you heard this week is that we're really not on track to do any of them. But a lot of people, when they first look at the Millennium Development Goals, think that really environmental stability only has to do with the 7th one. But if you think about what I just said to you about agricultural productivity, immediately many of these others, 1, 4, 5, as well as 7, are all dependent. Maternal health, the spread of diseases, childhood mortality, all of those are dependent on a stable environment. And if climate change is changing the environment so dramatically, I would argue we cannot achieve the Millennium Development Goals unless we actually tackle climate change. Now, I don't think we can say tackling climate change is impossible, because I would like to argue we haven't really tried. And this next chart shows you we spend the tiny little green bar on the right, $13 billion globally on energy R&D, public money in the world. And it's a tiny fraction of what those other orange bars are, which are the fossil fuel subsidies. So my French co-director of the World Development Report, Marianne Fay, said, okay, 13 billion, it's really tiny because the world's energy infrastructure is worth about $13 trillion. So you're trying to change something $13 trillion with 13 billion, but we need to give people a sense of how silly it is that it's this small. So her answer was that Americans spend $13 billion a year on pet food, and so shouldn't we spend more on energy R&D than on pet food? And I said, okay, but don't pick on us all the time. Could we have a French example? So her French example is that the French spend $13 billion a year on cheese. So that's interesting. So the entire world public investment in energy R&D equals what the French spend on cheese each year. Now there is a little bit of a hopeful sign. And if you click, there's been a recent upsurge in private spending on energy R&D. And that's now maybe up to about $60 billion a year. And so private energy R&D now far exceeds the public investment. But a way of measuring what appropriate investment is as a percent of revenue. So this would represent 0.5 or 0.5% of revenue. And that makes it an order of magnitude smaller than investments in R&D for, say, the electronics industry, which would be 8% of revenue, or in the pharmaceutical industry, which is 15% of revenue. So many reports have come out and said, this is just ridiculous. The public spending on energy R&D to make a major transformation has to be somewhere between 2 and 10 times what it is today. So we certainly don't say it will be cheap or easy, but we say it can be done if we're willing to do these 3 things: act together, act now, and act differently. The estimates are that it would take about 0.3 to 0.7% of GDP per year on average between now and 2100. So let me just go through some of our arguments on the now, together, and differently. So first, we argue that we have to act now because of the inertia in the climate system. So the gases we put up today will be up there for centuries to millennium. So if we want to change what's up there, we have to do it fast. And even if emissions peak in the world in the next few decades, it would still be decades to centuries until those temperatures equilibrate. So the very long lag time in the temperature is the reason we have to act now. But we also have to act now because of inertia in the built environment. And so the infrastructure investments we make are certainly long-lived, easily 15 to 40 years for factories and power plants. I think we're duct taping many of our power plants together so they're lasting 70 and 80 years. But think about road and rail and power distribution networks. Those are 50 to 75 years. And then whatever decisions you make about urban form and density of cities, those are issues that'll be reaping benefits or costs for a century. And by 2050, 8 of the 9 billion people on the planet will be living in cities. So the cities yet to be built or to be expanded in developing countries are very important and much cheaper to do it right in the beginning than to try to retrofit it later. And equally important, and perhaps why I make it the biggest cog there, is the inertia in institutions and behavior. And as Dale was telling me what I was doing 20 years ago, I was thinking, from the time of the passage of a law until it actually gets implemented, the Clean Air Act, which was the first thing I worked on, it's easily a decade or so. Once they pass it till something happens. But look at the Road to the Climate Treaty. I mean, it began more than 17 years ago with the Framework Convention on Climate Change, 1992. So changing behavior and norms really takes a long time, too. So to act now, if you switch to the next one, Regina, to have a hope of being anywhere on this 2-degree path, mitigation or emission reductions have to start immediately so that we get off that orange smear, which is a composite of modeling results about where business as usual might take us. And to have any hope of being on the 2-degree path, we would have to be on that green smear of emissions, which is quite a prodigious drop. And note that it essentially starts today. And note that by the end of the century, the emissions are pretty much zero. That is, we have taken all the carbon out of our now fossil fuel systems, which are all carbon-based. The way you can actually get zero or negative emissions is if you can actually stuff some of that carbon underground, or if you grow biomass sustainably, you could call that zero carbon. If you grow it, burn it, and stuff that carbon underground, you can actually get negative emissions. But anyway, that's a pretty big task. And so one thing is you'd have to start it now, and developing countries would absolutely have to lead the way, and that would be an important first step in order to trigger the needed investments to continue the decarbonization for the next century. And we argue that you have the technologies you need to begin today very dramatically, but the whole new generation of technologies that you're going to need coming online by 2040 are not really developed or remotely commercial yet. And so you need to push out into the marketplace the most efficient stuff that you have today, and you need to be developing the next generation if you believe it should be nuclear, if you believe it should be carbon capture and sequestration, if you believe it should be biofuels, solar, the suite of renewables. But the next generation of those need to be coming off pretty quickly. So we also argue that we need to act together. Again, this is again one from my French co-director. And we were trying to, again, give an example of how big or small a sacrifice is it. So this is if the 40 million SUVs we have in this country actually got 45 miles per gallon instead of 18 as they do now, and 45 happens to be the European new car average. That pollution space that would be freed up from going from 18 to 45 would be enough to power the entire rest of the world that does not have electrification, to the point of every household having 5 50-watt light bulbs. So the simple change in SUVs would be enough for 1.6 billion people to actually have electricity. It was a really startling statistic to me, but you all, as students and faculty, can recalculate. I think you'll come up to the same answer. And so her argument was, are we saying this is an enormous challenge, or are we saying it's something that's handleable? But it's pretty clear that all countries have a role to play. And many of you have heard about the famous McKinsey cost curve. So here what you see on the left side below zero are actions that are supposed to be free, or if you take them, make money. You see a suite of actions around zero cost, and then you see a suite of actions above zero that cost money. But what we asked them to do was to actually color code, so these are global, color code the options. Which are the developing countries? The poorer countries are yellow options, and the developed countries are red. And you see there's actually lots of these negative cost items in both developed and developing countries, and those tend to be improvements in efficiency. When you start coming across the zero line, you see a lot of developed country, the yellows, and a lot of those are land use changes. And then again, you see a lot of expensive ones. So if you just looked at the cost curve with the whole world playing, and then you look at the cost curve with only the rich countries paying, you see the enormous difference. So if you removed all the developing countries, the cost would rise very dramatically, and if you don't pursue the low cost. So developing countries will produce most of the future emissions, and many of them have the most inexpensive mitigation options. So it's very critical to produce the financing needed to be able to separate where the mitigation actions happen from who pays for them. We also have to act differently, because we've got to transform the energy systems of the world to have a hope of staying anywhere near 2 degrees. And energy services demand will probably about triple over the course of the century. So we would go from something like 400 exajoules to 1,200 exajoules. Now, all of the models say in order to make big reductions, you need at least 5 big wedges. The first and the biggest wedge is the one on top, efficiency improvement. So you immediately drop the energy demand by the amount of that red bar by using less energy to produce the same amenities in your buildings, in your cars, in your industry. And for example, in the United States, we can build homes that are 65% more efficient than the average. The next 2 bars below that, the, let's see, orange and yellow, is that right? Are non-fossil sources. Those are the biomass and wind and solar. And those need to very much expand over the course of the century. And so now you would pull the line down even further. And carbon capture and sequestration is that fourth big blue bar that you see there. And that's the idea that maybe you can still burn carbon-based fuels, coal, oil, and gas, but you take the CO2 and you stuff it underground. And so that makes it effectively very low or zero carbon. So all of the models assume you have to make great progress in those. But now look at the green wedges. There's also a tremendous capability of using terrestrial sinks, which in this chart are shown in the dark green, or going after the other greenhouse gases, not just carbon dioxide, but going after methane from landfills, from livestock, the nitrous oxide from fertilizers, black carbon, tropospheric ozone, and other gases. And so especially if you go after some of the shorter lived gases there, you could buy time. You could actually take a gouge out of the heat trapping or radiative forcing in the atmosphere that might help you get the next generation of technologies. So that suite of technologies is a possible pathway to put you on a 2-degree trajectory. But then look at the arrow heading down towards zero. So I show you out to 2050 what needs to happen. And of course, all of that has to be greatly expanded by the end of the century. One question was, how much carbon capture and sequestration would you actually need? And it turns out we have some pilot projects going on now. We're storing about 4 million tons of carbon dioxide through some pilots. But by the end of the century, that blue bar would have to go from 4 million to 22 billion tons. And if you start looking at how many windmills are built into this and how many acres of biofuels, it's a huge task. It's technologically feasible, but without political will, it's not going to happen. So we also have to act differently if we go to the next one, because we're going to need to manage our lands and waters differently. And so on the right side, you see that huge light green bulge. If the carbon that's held in trees and is held in soils isn't given a value, the natural thing to do would be to turn a lot of that land into land for biofuels, for what would be considered renewable energy. And that green bulge is taking a lot out of our managed and unmanaged forests. So it would have a very big impact on biodiversity. And it's only when the models run, as it is on the left side, where you value carbon everywhere, that you hold terrestrial carbon and forest carbon as important, that you won't have some of these side impacts that would damage other features of our lifestyle. I would argue that our ecosystems can't be destroyed at the cost of trying to reduce emissions. We're also going to have to manage land and forest and soils differently, but we're also going to have to manage for multiple stresses, as this next slide shows, because climate change will interact with a variety of other environmental stressors. Think of pollution and habitat fragmentation, invasive species, biodiversity loss, and they're all occurring concomitantly. So if you don't manage thinking about all those things together, you could be inefficient, or worse, ineffective in achieving one particular goal. So what this map is showing you in green are all the areas where we think the ecosystems will change type as climate change moves over them, as the map changes. But in orange, so all the green spots are going to change, but all the orange spots are the biodiversity hotspots right now. And so that is where biodiversity is very high, but where it's also being lost very fast. And the red circles then show you where we're on a collision course. If we try to save the biodiversity that's changing very fast, but the ecosystem itself is going to change type, we're likely not able to achieve a conservation goals. So we're going to have to think about managing for multiple things together to find some robust solutions. The next slide is a list of some of the options that we're going to need to think about. And we argue quite a bit in the report that we need to move to what we're calling this robust rather than optimal decision making. So if the past is not prologue, then you're going to have to think differently. You can't plan for water systems that'll have the water regimes of 100 years ago. And one of the big battle cries among the water engineers now is that stationarity is dead. You can no longer assume that the past is a good prologue. So then what do? I mean, we used to pick the best investment for an expected range of risk based on the probabilities of the past. And we don't really know those probabilities very well. So we argue in there that you really need to now, in this robust decision making, pick an outcome that it gives you a good set, will be useful and productive and resilient and robust over a range of uncertain futures. So maybe instead of the type of wheat that has the highest yield in an average climate, you pick the wheat that has at least decent yields across a range of climates that might include an increase in both droughts and floods and heat waves. You might want to think about seed varieties that perform well in a variety of these situations. We might, as I said a few moments ago, have to make decisions about what species can actually be preserved against climate change and those other multiple threats. We're certainly going to have an increased need for safety nets for the poorest of the world. And one of the issues that came up in our report that I certainly never expected was the need to improve insurance in the developing world. And we learned that 3% of the world's GDP is spent on insurance, but virtually none of it in the developing countries. And there are some interesting examples. There are 17 Caribbean countries that are pooling risk to manage and increase in extreme events. But the role of insurance going forward will probably be very much different We need emergency response plans, early warning systems, surveillance systems to protect people. Certainly better monitoring and weather information in real time. And it's really shocking when you look across the globe. You know, you would think that Boulder, Colorado is the most important place on the globe because of all the monitoring networks that are there, in part because of the Center for Atmospheric Research. But huge parts of Africa are essentially not monitored well at all for hydrologic data or in terrible states of repair. And so those are not extremely high-tech things, but things that can help give communities real-time information and help them prepare now for a changing climate and be ready for the changes ahead. And one thing that I feel very strongly about that we should just get on with is producing a set of kind of best practices. How do people deal with extreme weather events now? How do working rivers handle combined sewer overflows? And I think beginning a compendium of shared best practices from communities and regions around the world would be very important. We're going to have to act differently, and I put on this map one that I think is quite illustrative of something that's very little studied, which is the intersection of how the options we might choose to reduce emissions or mitigate climate change could interact with our need to adapt to climate change. So right now on this map, the darker the county, the more biofuels, and I believe this one is switchgrass, you could grow. And then if you click, the area that just blew out there was the area that the drought of 2007 would have taken out in terms of producing biofuels. So again, competing demands for land and water, how a changing climate will interact with your attempts to mitigate climate change or adapt to it need to be considered together. Adaptation is a word that was really not used very much for the last 10 years, and I think it's something that we need to think about a lot more. The changes that climate's imposing on us are already becoming evident. As I told you, especially in Africa, they believe that the climate shocks are increasing and they're not coping with them well. And so I'm really pleased that, although I've been reminded it's 17 years later, we are releasing tomorrow at a conference a new climate change adaptation summit report. I was privileged to lead it in May, which brought together, probably for the first time, people, half of the conference are people from cities and states and regions and users of climate data with scientists and academics who were creators of data to talk about what adaptation needs they have. And on the bottom, I guess you can just barely see the website, and we'll have a webcast tomorrow. But we're calling for a federal strategy in particular to help build the research database with the communities that will help us all cope. With regard to resources, so I said we have to act together, act now, and act differently. And there are some signs of hope. There are some signs that new finance instruments are helping to build momentum. And in this next slide, I show you, I think, the green stimulus packages of a variety of countries. So here, the size of the blue square is the size of a stimulus package in that country, and the size of the green is the portion, the stimulus is blue, and then the green part of the stimulus package is in green. And so you can see that some countries put quite a bit of money into it. I think it adds up to something like 400 billion in green stimulus. There was something like more than 200 billion put into energy efficiency, some 38 billion into renewables, 20 billion into carbon capture sequestration. And you can see that 40% of China's stimulus package was actually dedicated to green, and virtually all of Korea's. In the US, we dedicated about 15%. So that's a jump start on thinking about green technologies writ large, of which at least 300 billion of that 400 billion we would call relevant to mitigation. But we're going to need new resources, as the next slide shows. We currently generate about $10 billion a year in climate finance, about 9 of it for mitigation and about 1 of it for adaptation. But if you look at the big orange bars on the right, we projected that the need would be about $70 billion for adaptation and 100 to 150 billion or perhaps more than 200 billion per year by 2030. And that's an average annual cost. You'd actually need to put more upfront and you'd get some of that back later. So the upfront financing cost could actually be as much as $550 billion, but then you get money back from energy not used or disaster averted. Now the private sector, if there were carbon markets of significant size, could certainly provide a significant portion of it. So can it be done? Well, the costs, as I say, are about 0.4% of high-income GDP each year to 2100. And the upfront financing is about 3% of current global investments. But these, again, are sort of these best costs. This is assuming you can use everything on that cost curve. So I leave it to you as to whether that's enormous or small. But closing that will require all the tools at our disposal. So reforming and scaling up the carbon markets would be really important. And so we do have something called the Clean Development Mechanism, where emission reductions can be gotten in developing countries and be certified, and then they can be used by a developed country that actually has a target. And currently 85% of those Clean Development Mechanism projects are certified in only 3 countries, India, China, and Brazil, and virtually none in the least developed countries. And right now you have to get them certified project by project by project. So it's a tremendous amount of work to do that. But if this could be reformed and perhaps move to a more sectoral approach, that would be promising. Reduced emissions, REDD, from deforestation and degradation. The amount of carbon that would be released from expected future tropical deforestation in the coming decades is about the carbon in a decade worth of energy emissions. So if we can keep those tropical rainforests from going up in smoke, we can reduce the rate of greenhouse gases going into the atmosphere. You've seen that that's a very strong wish of the developed countries going into Cancun. We'll see whether anything comes out, but reduced emissions from deforestation and degradation, really a deal breaker for the developing countries if it doesn't happen. And then questions of could we ever get to the point of really figuring out how to value soil carbon and land use practices that keep that soil carbon in the ground when we know that the first time you till will release it. But are there ways to monitor and to measure that? We're certainly going to have to activate the private sector, and that's certainly going to require better information on both climate trends and on climate risk. Pricing carbon will certainly generate finance within countries, but it doesn't automatically create flows of finance transferring across the borders. And then that requires some sort of fiscal transfer or allocation and trading of emission allowances. So if developing countries were given sufficient allowances that they had room to grow, then they could sell some of those to rich countries. But you can see how complicated this all is. And then you put on top of that the adaptation finance. If we had that $70 billion a year, how would you allocate it and to whom? I hope you wouldn't use it only for disaster response, but the developing countries are very clear that any adaptation monies have to come on top of overseas development assistance and not suddenly be a blending, a merging, or a dilution of that. So lots of very difficult things to work out. So the policy tools that we employ certainly have to be tailored to the maturity and the cost of technology. And so here the blue line is again that cost curve that goes from negative to positive. And so you could argue on the left side of that curve, that's allegedly sitting on the ground fruit that we're not picking up. Most of those are energy efficiency measures, and they're financially viable for investors at current prices because they're negative cost on the McKinsey curve. But achieving that huge potential requires some policy measures like standards and codes, financial incentives, fuel tax and consumer rebate. And so we're going to need innovative financing and institutional reforms to get that clump. Then as you move across the middle section of the graph, many renewable energy technologies, I would argue, are economically viable, but not financially viable. And by that I mean not competitive yet, cost competitive with fossil fuels, except for hydro. So what you need there is a suite of policies that actually level the playing field between renewables and fossil fuels. And so the choices are you subsidize renewables, or you tax fossil fuels, or you find some way to do both of it. And then how to get that right side of the curve, that's the developing the whole next generation of new technology, such as carbon capture and sequestration, truly penetrating electric vehicles. And in order to make that happen, the pathetic $13 billion that I cited for RD&D has to increase, and we have to finance some of these incremental costs as well as facilitate technology transfer. So I do think, though, that there is hope, that things are moving a bit. The drumbeat of science is louder, as you see the IPCC reports. There's 3 of them. We have seen that individuals, business, and organizations are responding to taking on voluntary targets, and they're marketing that fact as being environmental has a real value in the marketplace. We're seeing that cities and states and countries are taking action. Right now, it's more than 1,000 cities in the United States have adopted the Kyoto targets, which would be 7% below 1990 levels, and at least 36 states have renewable portfolio standards. New York City is quite a leader in that you have both a mitigation plan and an adaptation plan. Your state has a plan. The politics are changing, although not as fast as we would like. We've actually seen the choices in some countries being made on their environmental stance or their climate stance. And I really had hoped, but there are now question marks again, that there would be legislation. Appears not to be that likely. And we really had hoped that, of course, there would be a climate treaty. I think there will be one. I don't think we have extremely high hopes for Cancun, but we must soldier on and continue moving. And then we really have to do more to turn what awareness really into action. And I think there has to be a lot more communication and education. And we do know that transformational change can happen. There probably aren't too many of you in the room old enough to know Humphrey Bogart, but I'm just showing you that in a generation ago, he was very cool and a heartthrob and an idol, but you never saw the man not smoking. And if you click, my niece said to me, Aunt Zena, nobody smokes anymore except Cruella de Vil, and she steals Dalmatian puppies. So it is an interesting cultural change that has happened, unfortunately over generational, but it is possible that I think we need to make the invisible smoke that we produce, carbon dioxide, equally unsavory with future generations. I wanted to just show you, to remind you where the haves and the have-nots are. This is a picture of the world at night, and to me, it just always brings home where the world is dark. And you see those tremendous areas of Africa where most of those 1.6 billion people without electricity are. And it is in the generation of these students that those areas will get lights. And depending on what fuels those lights will determine whether we have a chance of staying at the 2-degree world or we go soaring right into a 5 or 6 degree world or beyond. So I wanted to conclude by showing you one last time, the WDR is a call to action. The priority has to remain growth and poverty alleviation, that development is imminently and seriously threatened by climate change. We have to acknowledge how difficult it will be to make the necessary changes, but we assert that it must be done, and we assert that we have to act now because to break our high carbon habit, to manage natural resources better, so that we can be more resilient, to reduce the vulnerability of people and ecosystems to a whole suite of environmental insults, of which climate change is one. We argue that you have to act together to develop the new technologies that have to be in place by 2040. We have to learn by doing, adapt adaptively, and we also have to protect people and ecosystems from an increasing spate of extreme events. And finally, we have to be very different in how we act. That climate smart does not mean business as usual. We have to develop price signals. We have to value things like ecosystem services. We have to think about things like a green GDP. And we have to plan for a future that is very significantly different from the past and adaptively adapt. And I wanted to end with a quote from Maria Casabian, which is the next slide. And she says, "It is our collective responsibility to find unselfish solutions and fast before it's too late to reverse the damage caused every day." And I think that indeed is a good mission for all of us. So with that, I thank you very much for your attention, and I'll entertain questions.